Hello math learners, my name's Nikita. I am coming from the Gavilan Writing Center to make you guys a math video. Gavilan Writing Center provides many tutoring opportunities, in person and online, where most of the learning is done, but it also provides these online learning resources, which I love recording because you can watch them whenever you can, which means you could do your learning there. Today we'll be talking about the art of factoring. Math is everywhere. As I'm sure you all know, math is in your homework, math is in your food, and math is in your receipts, where you figure out how much everything really costs. But today we'll talk about the secret weapon of algebra, which is factoring. Factoring is basically breaking things down into smaller parts. It's like breaking a shape down into smaller shapes. Or it's like having a certain calorie goal that you want to reach by the end of the week, and you break down your meals. You start meal prepping. Step 1 in factoring would be to find out what all your terms have in common and pull them out like a magician pulling out a rabbit from a hat. Except here, the rabbit is a number or a variable. Our example, 6x squared plus 9x. We see here that we could factor out a 3 from both sides, but we can also factor out an x. So we factor that out. We have 3x and 2x plus 3. Boom, factored. Now let's move on to something a little more complex. Trinomials. Say we have x squared plus 6x, or let's actually do x squared plus 5x plus 6. What we're going to do here is we're going to find two numbers that multiply into 6, but add together to get 5. Why, you might ask? Well, let's take a look. A very common factored form is x plus a times x plus b. If we FOIL this out, we get x squared plus ax plus bx plus ab, or x squared plus a plus bx plus ab. What can we take from this? We see that to get this ending number, we need to multiply the a and b together, and to get the coefficient of x, we need to add the a and b together. So in our situation, we have to find two numbers that multiply to get 6, but add to get 5. Now, with a little bit of thinking, we can come up with 3 and 2. Now, all we do right now is we rewrite it. We have x squared plus 2x plus 3x plus 6. And this is just rewriting this original equation. They're equal. But you make it easier for yourself to factor. What do we do next? We split it up. We isolate the left and right side so that we can focus on them. X squared plus 2x, what can we factor out there? Well, we can factor out an x, and we're left with x plus 2. 3x plus 6, what can we factor out there? We can factor out a 3, and we're left with x plus 2. Now looky here, this is a really important part. This x plus 2 and this x plus 2 are the same. This shows that you have factored correctly. If this parenthesis is not the same as this parenthesis, that means somewhere along your lines of factoring, you have done something wrong, and you should probably go back and just restart. But what this is useful for is that this can act as your halfway point. Knowing that these have to be the same, you can always check and see, okay, well, I'm going into the right direction, and I could keep going, or, oh, I have to go back and check my work. Now that we have that out of the way, see, we have x plus 2. All we do, we just move it down. And what do we have left? We have this x and this 3. We move it down here. And our factored form is x plus 2, x plus 3. We multiply it out just to see. And we get, oh, looky there, little old original equation. Let's try an example for you guys. Look at this and following the previous steps, try to factor it yourself. Here you go. I'll give you guys some time to do so. So pause the video. I hope you guys have taken the time you need and have solved it. Let's go through this step by step. Let's take a look. 9, you could multiply 3 and 3 together to get 9, and you can add 3 and 3 together to get 6. Rewriting this, we get x squared plus 3x plus 3x plus 9. We separate the terms, factor out the x, we're left with x plus 3. Factor out the 3, we're left with x plus 3. We see that these are the same, give ourselves a nice little check mark. Bring the x plus 3 down. We're left with x and 3. Bring it down. And look, in this part, we can write this factored equation as x plus 3 squared. This actually brings me towards another rule, which is whenever you have a factored form and it's squared, so we have x plus 3 squared, the answer will be the first variable squared, so x squared, plus the 3 times the x times 2, so 6x, plus the ending variable squared, so 9. So if we rewrite this into a formula, let's say we have x plus a squared. If we want to rewrite this from factored form into this form, we will have to FOIL this out, and we'll get x squared plus 2ax plus a squared. And as we can see here, in this specific example, x plus 3, we get our x squared, then we get 2ax because we multiply 3 times x times 2, giving us 6x, and then we have a squared, giving us the ending 9. I hope you guys got that right. Let's go to something more sneaky. Let's say we have a coefficient in front of our equation. Let's say we have 2x squared plus 7x plus 3. What do we do here? Well, here we do what I like to call the AC method. And no, I'm not talking about the AC that you have when it's scorching in the summer and it keeps you cold. Not this AC method. I'm talking about this AC method. This is a representation of the trinomial ax squared plus bx plus c. What you do in the AC method is you multiply a and c together. In our equation, 2x squared plus 7x plus 3, we would multiply the 2 and the 3 together to get 6. Now, we'd find two numbers that multiply together to get 6, but add together to get 7. Thinking about this a little, we can find 6 and 1. We rewrite the terms 2x squared plus x plus 6x plus 3. We split them up. We factor out x. What's left is 2x plus 1. Move on here. We factor out a 3. What's left is 2x plus 1. Give ourselves a big old check mark. We bring it down. We have this x and 3 left, x plus 3. And this is our factored form. As you may tell, it is pretty similar to how we factor it without the coefficient. You just have to multiply the a and the c together. Let me give you guys an example to work for yourselves. So please, for me, could you factor 3x squared minus 4x minus 7? Pause the video. I hope you guys are back and have factored it like a pro. But let's do this together in case you're stuck. So we use the same method. We multiply 3 and negative 7 to get negative 21. We think, okay, what multiplies to negative 21 and adds to negative 4, we can figure out that it's negative 7 and 3. We rewrite this 3x squared plus 3x minus, 3x squared plus 3x minus 7x minus 7. Again, these two equations are the same. We split it up. We figure out, hey, this factors pretty nicely. We could take out an entire 3x, leaving us x plus 1. The negative 7x minus 7, wow, very nice. We factor out negative 7, x plus 1 is left. We see it's the same. Move it down. And as I hope you guys have found out already, this is our factored form. There, factored like a math ninja. Right, so where could you guys apply this in a broader math context? Well, let's say you have a graph of this function, because 3x squared minus 4x minus 7, this is just a function. Or most representative, this is just a function of x. So you plug in x values here to get the output of y values. And this specific function looks a little like this. So you might be asking, okay, Nikita, well, what does this have to do with factoring? When you factor this equation and you get yourself your x plus 1 and your 3x minus 7, you usually in these graphs, you try to find these x-intercepts when y equals to 0. When y equals to 0, you have these x-intercepts that cross the x-axis. How do you find these? Well, all you do, you know that f of x, that's like y. So you set that equal to 0. And when you factor it out, you keep that 0 there. So now, okay, we could think about this logically. X plus 1, if this entire equation is equal to 0, then it doesn't matter what this is because it's 0 multiplied by something, which is going to be 0. Then if we have 3x minus 7, if this thing equals to 0, it doesn't matter what this is because it'll be that times 0, which equals to 0. So we need to find two x values which will produce a 0. So what we do, we just move this here, x plus 1 equals to 0. An x value that could satisfy this is negative 1. So when x is equal to negative 1, this part is equal to 0. Then we have 3x minus 7 equals 0. A little bit more work. We add 7 to both sides. 3x equals 7. Divide by 3, 7/3. So we know that when x is equal to 7/3, this entire thing equals to 0 as well. So our two solutions is x equals negative 1 and x equals 7/3. And as you could see here, this solution would be negative 1, 0, and this coordinate would be 7/3, 0. And you can check yourself, that would be the coordinates. So now that you see what it's like in a broader context, I hope you guys know that factoring is just like solving a puzzle. And math is filled with these puzzles. And except the pieces always fit if you know the rules to them. So next time you see a polynomial, don't panic. Factor it like a pro. And if you get stuck, just remember, math is all about patterns. And every pattern will be able to be solved. I will see you guys next time. Thank you. Visit the Gavilan Writing Center for more information. See you.